Hello everyone. So let's start with the lab program. So today I'm going to start with the 7th sem Aiml lab program, that is AO star algorithm. This is our second lab program according to the syllabus. So let's start with this AO star algorithm. So to begin with, let's understand what is this AO star. Here A means and, O means or, star means admissible. It means that it will give the solution at any cost. It will not uh, there will be no case such that there will be no solution to that given problem. So the main agenda or the main aim of this problem is to find the minimum cost between 2 points. Say for example, you are at the position A and you need to reach to position D. So from A to D you need to travel. So which is the minimum path in order to, minimum cost path in order to travel from A to D, that can be determined with the help of AO star algorithm. So we have many other algorithms like A star and DFS, BFS and etc. We have salesman person problem also. So there are various algorithms. So here in AML lab we are learning about AO star algorithm. So this is the graph. There is a slight difference between A star and then AO star. Here I said A star is nothing but just an and graph or just a normal graph. But AO star means here you have and or graph. So in the graph you have both and or. So let's see how this difference is indicated. So begin with, so as you can see in this diagram, here you can see there is one arc. Here one arc is there, here one arc is there. It means that it is and arc. If there is no any arc is not mentioned, then it is not or arc or side or path. Okay, so whenever you are trying to move in this path or in this BC, so wait, I will just draw this again. So here you have A and here you have B and C and then D, correct? So BC is having and arc and D is not having any arc. So whenever you need to travel to the position, for example F, you need to travel through either B, C, D. So this is the problem. So if there is any and arc, then you have to consider these both path also. Whenever you are traveling in or path, then you can consider only single path. So in order to travel through this position, you need to travel from A, B, C and then F, or you can choose A, D, F depending on the cost. So we need to travel. So here in this problem, look at this diagram. Here in this problem, here A, B, C. So here the nodes of child nodes of A is B, C, D and G, H, I, J, E and then F, I. So here you need to find the minimum cost path. The cost of this each node is 111 and the heuristic value is 162 is defined as follows. And the solution here, as you can see, as I said, so this is 12, here you have 12 and 12 plus 1, the solution for this will be 13. While considering this path, you need to travel both, I said. So 6 plus 2 8, 8 plus 1 9, 9 plus 1 10. So this side you have 13, this side you have 10. So which is minimum? 10 is minimum. So you need to choose A, B, C, this and arc path. I hope this is clear. So let's go on with the program. So yeah, I will start with the program. First I will explain what is the use of each function. So here you have various functions defined. So I will explain what is the use of each function. Then I will go with the program execution or the workflow. So to begin with, here first we will start with the class graph. So here we have defined one class graph, so then we can derive one object using this class graph and we will execute it. So let's begin. So here you have defined init function is used to initialize the variables. So we have init function and we have init functions. In init we gonna pass graph, heuristic node list and then start node. These are the three variables we are going to pass while calling this init function. So yeah, so init function is used to initialize the variables, I said. So where we are initializing this values, graph to graph, heuristic node list value to H and then start node to start. Apart from these three values, we are initializing or we are declaring one new three values, that is parent, status and then solution graph. So what is the use of this parent? For example, you are traveling from A to D. Okay, so you have reached this D through A. Then I can say that the parent of D is A. So in order to keep track of this parent and then child relationship, we use this parent dictionary, and in order to keep the status. For example, I have A node and A has D and then B node. Okay, so if I explore this D and then B node as well, then I no need to visit this A again, correct? So it is already explored. So in order to keep track of the node status, to keep track that whether the node has been visited or not. If it is explored, if it is visited, or if it is completely explored, then no need to visit that node again, correct? So in order to keep track of that status, we will use this dictionary. For example, if the status of this is -1, then this has already been explored. If the status of this is length of this child node, that is 2, then it is not yet explored. So that is the condition. So we will declare each status of the each node. We will store it here in the status. And the solution graph, as the name says, this is used to used to store the solution. And then next we have define apply AO star. In this function, we're going to call another one function, that is AO star function. Here we are calling another one function. What are the parameters we are passing? We are passing star and then false. So start is nothing but the start node, and false is nothing but this is a boolean value indicating that whether we are doing a backtracking or not. If it is false, then we are not doing backtracking. If it is true, then we are doing backtracking. So that is this one. And the next, get neighbors. As the name says, this get neighbors is used to get the neighbor values of that node. For example, if A is there, the neighbor of A is DB. So in order to get this DB, so we will use this get neighbors. What we will return is self.graph. That is this one, graph.get of V. Graph of get of V. V is nothing but, so this is used to get the neighbors of V. Okay, so and then next, moving on to the next condition, so moving on to the next function, that is get status. Here it is used to get the status of the each node. This will be returned by some value, that is self.status of get of V, 0. If any value is not defined, then we will replace that with a 0. So and the next function we are calling is set heuristic node value, heuristic status, that is set status. Set status is used to set the status of the each node. So I said so here we will pass two variables, that is V, the current processing node, and value. So value is nothing but the status value what we need to store. How we will store? Self dot V is equal to status. Status of V is equal to value. So that is how we gonna store. And then next we have get heuristic node value. Here we will get the heuristic node value. Heuristic value is nothing but each node has some particular cost. The path cost is different and the node cost is different. The node cost is nothing but heuristic value. In order to get that heuristic value, we use this heuristic node value. And the next one is set heuristic node value. Whenever the cost is minimum, we will update that to the minimum cost. So in order to set that, we use this set heuristic node value. How we will assign h of n is equal to value. And the next one is print solution. This is used to print the solution. Solution will be in the solution graph. And the next we have compute minimum cost child node list. So as the name says, this function is used to compute which is the minimum function we have. So for minimum cost child we have. For example, I said for example you have A and you have one variable D and another variable is B. Okay, so now you have two paths, either you can travel to D or either you can travel to B. So how to identify which is the minimum cost? So this has some value, say for example 1, this has got some value, for example 2, and this path has got some value, that is 5, and this path has got some value, that is 6. Okay, so how we will identify? So first you need to calculate the total cost of this value, that is 5 plus 1 6, and then next you need to calculate this total cost of this node value, that will be 8, which is minimum. Then you need to choose that. So okay, so if it is AND graph, then we have to consider both. Then we have to consider both, correct? So that is why. And so first we are passing a variable V, and here you have minimum cost is equal to 0. So the minimum cost variable is declared here, and a cost to child node list dictionary in order to keep track of all the child nodes available. And the next one is cost to that child node, and the minimum cost of that child node is declared here, and we are declaring one variable, that is flag is equal to true. So this value, or the use of this boolean value, is defined here. And next, so what we are doing, we are looping, that is for info node tuple list in self.get neighbors of v. What we are doing, so we are taking the neighbors of v. So the neighbors of a is d and b, correct? So the neighbors of a and d, a is d and b, correct? So in order to get the neighbors, we use this get neighbors of v. Each value of each value, that is neighbors, will be assigned to this info node tuple list. First d is considered, it will be assigned to this one, and then b is considered, then that will be assigned to this info node tuple list. That is how looping works. And here we are initializing one variable, that is cost is equal to 0. So cost is equal to 0. And next we have one node list, that is a list, and next we have c comma wait in info node tuple list. So I will explain what is this c comma wait in info node tuple list. So info node tuple list is this node, correct? So c comma wait, when so this is the graph what we have defined. So here you have graph what we have defined. So the neighbors of a is b, c and d, correct? So this will be returned. So first we have b comma 1 in info node tuple list. So here we're gonna consider c comma wait. So here b, the value of this is c, and the value of 1 will be considered as wait. Okay, so now in the c comma wait, what we have is b comma 2 or d comma 1. That value will be there in c comma wait in info node tuple list. And then next, cost is equal to cost plus self dot get heuristic node value plus wait. So I said, in order to find the cost, you need to get this heuristic value, that is this heuristic value, and the weight, correct? So that will be calculated. So that is get heuristic node value plus weight with the previous value. For example, if we have AND OR, then you have to consider both. So that is why we add that to the variable cost, and we will append that to the node list. So whenever the flag is equal to true, that means that we haven't calculated any minimum cost yet. That is, this is the first node we are exploring. If this is the first node we are exploring, then this value will be the minimum cost. So that is why we are assigning the cost what we got to the minimum cost value. So and then we are assigning to the node list, and we are changing the boolean value to flag to false. Okay, so now if that flag is not equal to true, then that is not the first node we are exploring. Then we have to check whether the cost what we got is less than the minimum cost what we have assigned. So as I said, first we will say, for example, first we will take for example, a, b is the node we are looking after. So then the cost will, now the minimum cost will be 8, since this is the first node is explored. So now I'm exploring the second node, that is D. So here you got value 6. So we are checking that whether this minimum cost, that is 8, is less than the cost what we got. If it is less, then what we have to do, we have to assign this value to the minimum cost. That is what we are doing here. So if minimum cost is greater than cost, then minimum cost is equal to cost. Then we have to append that value to the node list. So child node cost to child cost list dictionary, we are appending that value. So what we are returning here is, we are returning the minimum cost was what we got, and that cost to child node list dictionary of that minimum cost. With that minimum cost, how many nodes we can travel, or how many nodes we should travel. So that is returned here. And then next, coming to the next function, that is define AO star. Here this is the very main function, we can say. So first what we will do, we will print these values, graph, solution graph and processing node. And then next, what we are doing here is we are getting this, first we will check the status, whether the status is greater than or equal to 0. If the status is greater than or equal to 0 or -1, then it is indicated that it's not been explored. Correct? So first we will call this compute minimum cost child node list function. Here it will return two values, as I said, cost and then list dictionary. So that we will assign that minimum cost to the cost and cost to the child node list dictionary to the child node list. And we are setting the heuristic node value, because since we got the minimum cost, we need to change the heuristic value. How can we change the heuristic value? With the help of this set heuristic node value function. So here we are passing the node and the minimum cost need to be assigned. And the next we are setting the status, that is v comma length of child node list. I said if it is not yet explored, then we have to assign the status as the number of child nodes available. So we are assigning the node v with the child number of the child node list available. Then we are checking that when we are initializing that node salt is equal to true, one boolean variable. So for example, and the next, first we will check for child node in the child node list. If parent of child node is equal to v, then yeah, so for child node in the child node list, for each child node in the child node list, what we are doing here is we are assigning the parent value. So the parent of this child node will be this v value, correct? So we are going through the child nodes of v, so then child node parent will be v, correct? So we are assigning this parent of child node is equal to v, and we are setting the getting the status. If the child node status is not equal to -1, then it is indicated that it's not yet solved. That means it's not yet explored. So that is what we are doing. So we will assign salt is equal to salt and false. So if salt is equal to true, then what we will do, then we got the solution. We have to set the status of v as -1 and we have to append that value to the solution graph. And then next condition, if v is not equal to the start node, if a is not the start node, then what we have to do, then it means that we are exploring some other node. So then we have to pass this node again to AO star function. So what AO star function we will do? So here it will explore all the nodes of this B. Again the process will start from the beginning. Again nodes will be calculated. Again everything will be done. And then next, if backtracking is equal to false, then that means we are not going back again. So backtracking is equal to false, then what we have to do, we have to set the child node and its value as 0, and we are calling one AO star function. So again we are doing the backtracking. It means that we are processing that node again. That means we are not, if we have solved it, we are not going back and again we are not coming here. So that is why, so we will pass the AO star, we will call the function AO star and we will pass the variable as false. So this is indicating that we are not yet, this is not the backtracking. And next, this is the end of the function defined. So here moving on to the next one, here we have defined heuristic values, and here we are calling the functions heuristic values and then graph. So how to define the graph? How can we define the graph? So so I said, wait, I will show you. Yeah. So the heuristic values will be defined like A heuristic value is 1, B heuristic value will be 6, and C is 2, D is 12, and E is 2. So we have to call one dictionary and then we have to assign. So how can we define this graph? Because since it's a completely different graph from the other, we need to declare one some kind of strategy, right, in order to indicate this AND arc. So how we will do is, we will enclose that with the square bracket, that is list of list. So here, as you can see, I will erase it. Hope you can see. Yeah, so now I have erased. Here you can see that BC is enclosed with one square bracket and D is enclosed with another square bracket. BC is AND arc, so this is enclosed in one square bracket and D is enclosed in another one. So in G and H, this is enclosed in a separate individual brackets. And again you have D, E, F as an so AND arc, so that will be D is equal to E comma F, that will be enclosed with the same brackets. So that is how it is defined. And now, so here we are passing one variable. So what we are doing is, I said class graph. In the first line we have defined class is equal to graph of graph1 comma h1 comma a. So whenever you are calling this class graph and we are assigning that value to the G1, that indicates that we are creating an object. So G1 is an object, we are passing the value, that is graph1, that is this graph, and then h1 heuristic value, and a is the start node. We are passing that to the G1, so the variable initialization will be done. And then next we are calling one function apply AO star. Apply evo star will call function, so we'll go through it again. So class graph, I passed the graph 1 and then h1 heuristic value and the start node as a. So it will be initialized and this will be done, and then apply evo star function will be called. Whenever you call the apply evo star function will be called. Whenever we are going to the evo star function, here cost evo star function, here compute minimum cost child node list function will be called. So like that you have a link between all these functions. So remaining functions, two main functions is compute minimum cost child node list and the evo star algorithm, and the rest is used to get and then set values. So that is how it is done. So this is the program. Yeah, thank you for watching. If you want this program, so I will add the or I will link the file of this program in the description. You can refer to that program. You want a very small program. In some colleges they have used direct modules. For example, some pre modules is used. So just they have imported it and they have passed these values that up from here to here, and that's it. The program is end. And that's a simple program. So if your college is not accepting that program, please refer to this one, or else you can refer to that program only. I will attach that code also. So that's it for today's video. I'll upload all the lab programs video. Kindly refer to it and do well in your lab exams. Thank you.